So hello friends, welcome to my new video. So today in this video I will discuss with you all about a very important topic that we all need to understand properly. So I'm telling about the term that is astigmatism, right? Astigmatism. It is quite very much confusing sometime when to do the retinoscopy and getting the axis and all. So I uploaded a video on subjective refraction on how to refine the astigmatism axis, and also previously I upload video on the type of astigmatism, right? Like where I told about the simple myopic astigmatism, simple hyperopic astigmatism. So today I will tell you other types of astigmatism. So I'm telling about the anatomical type of astigmatism. Okay, so if I tell about the astigmatism, what is astigmatism? Suppose this is your eye, and here the parallel rays of light rays which are coming from infinity after getting focus, if they are getting focus on two separate points rather than focusing on a single point, then it is leading to astigmatism. Suppose this is compound myopic astigmatism, right? Or suppose one light is getting focus in front of the retina and another light is getting focus on the retina, that means it is simple myopic astigmatism, right? So astigmatism can be two types in an anatomical manner: corneal astigmatism or lenticular astigmatism. Okay, so what is it? Astigmatism can be two types, that is corneal astigmatism and lenticular astigmatism. Okay, so we will discuss first about the corneal astigmatism. Okay, so let's talk now. Cornea, suppose this is the cornea and you will see here is the vertical meridian, here is the horizontal meridian. Okay, so if in the cornea the vertical and horizontal meridian curvature is quite very significantly different, and because of that they are having two separate refractive power, that is leading to astigmatism. Suppose in the vertical meridian the refractive power is 43.0 diopter and in the horizontal it is 44.0 diopter. So the amount of corneal astigmatism is equal to 1.0 diopter, right? So this is the corneal astigmatism. Now what about the lenticular astigmatism? So lenticular astigmatism, let me focus remove it first. Fine. So if this is the cornea, this is the lens, and this is the retina, and light rays are coming in this manner, hit the cornea. Now if the curvature of the crystalline lens is not uniform, or the lens is quite tilted manner, something like that, it is tilted in a quite backward manner, so the curvature is not same, and because of that it is leading to astigmatism, that is lenticular astigmatism. So the astigmatism which is because of the cornea, that is corneal astigmatism, and astigmatism because of the crystalline lens irregular curvature, that is lenticular astigmatism. So when you are doing the retinoscopy, you get the total amount of astigmatism. So total astigmatism is equal to corneal astigmatism plus lenticular astigmatism. Okay, there is another term related with astigmatism, that is residual astigmatism. What is residual astigmatism? So when you are fitting spherical RGP contact lens to the cornea, then after fitting the spherical RGP contact lens, the remaining astigmatism that you will get it, that is the residual astigmatism. So how to get the residual astigmatism? So residual astigmatism is equal to total astigmatism minus corneal astigmatism, and this will give you the residual astigmatism. Okay, so if the residual astigmatism is more than 0.75 diopter, then definitely you need to go for the toric soft contact lens or toric RGP design contact lens to deal with this thing, because if the cylindrical number is less than 0.75, then the patient will not be that much symptomatic if you give the spherical equivalent and all. But if it is more than 0.75, that is a significant cylindrical value. So this is why you definitely need to go for the toric soft contact lens design to give the patient more satisfied visual acuity. Okay, so this is how it is done. Now let me tell you another thing. So now let's continue our discussion. So here another way that astigmatism is also there is a revision that I am giving to you. Type like AST, astigmatism is two type: regular astigmatism and irregular astigmatism. So let's talk about the regular astigmatism and irregular astigmatism. So regular means, suppose this is the cornea and you will see the vertical meridian is the horizontal meridian. So regular astigmatism is three type: with the rule astigmatism, against the rule astigmatism, and oblique astigmatism. This is the regular astigmatism. Okay, so here if I tell with the rule astigmatism where the vertical corneal curvature is more steeper than the horizontal corneal curvature. So if you are giving the minor cylinder, then axis of the minor cylinder will be in the horizontal meridian, right? Like minus 1.0 into 180, this is the regular astigmatism. But in the same thing, minus 1.0 into 90, this is the against the rule astigmatism, where the horizontal corneal curvature is more steeper than the vertical corneal curvature. Okay, so this is how it is done. Now let's talk about the oblique astigmatism. So in oblique astigmatism, you will get axis like 30 degree, 60 degree, where their addition will be 90 degree. Okay, or 30 degree and 150 degree. Okay, so the addition will be 180 degree or 90 degree, but they are not perpendicular. Like this is oblique astigmatism. And what is irregular astigmatism? Irregular astigmatism is generally seen in keratoconus and also corneal scar or corneal ectasia. Okay, so in this kind of cases you will see irregular astigmatism where the cylindrical axes are not at all similar with each other, and definitely they are quite very different, right? So these are irregular astigmatism. And another thing, like if I tell you about the revision perspective, this is the cornea. So if light rays after getting refracted in the cornea, okay, if it get focus on the retina, this is known as emmetropia, right? If it is focus in front of the retina, it is myopia, right? If it is focus behind the retina, it is known as hypermetropia. Now one light ray get focus on the retina, another light ray get focus in front of the retina, this is simple myopic astigmatism. Now one light ray get focus on the retina, another light ray gets focus behind the retina, simple hypermetropic astigmatism. Now one light ray both light rays get focus in front of the retina, that is compound myopic astigmatism. Okay, and both light rays get focus behind the retina, that is compound hypermetropic astigmatism. And suppose one light ray get focus behind the retina and another light ray get focus in front of the retina, that is known as mixed astigmatism. Okay, so this thing that you need to understand it very properly, that what is which type of astigmatism. So that's all friends, thanks for watching, and please don't forget to like my video and subscribe to my channel. I hope this short video helped you a bit in understanding about the astigmatism properly. Thank you so much.